Hey everybody, I want to spend a little bit of time preparing you to name ionic compounds, and in this video we're going to go over naming just regular old ions and building up to the naming of all sorts of ionic compounds. So before we even get into naming ions, we have to first start kind of recognizing what an ionic bond is. And so an ionic bond is usually between a metal, like anything like sodium or lithium or gold or silver or whatever, and a non-metal. Okay? And so we're basically talking about two different sides of the periodic table. We're talking about, if we have I'm going to draw a little itty-bitty periodic table here. Okay, we're talking about the nonmetals here and the metals here, so we're talking about things that bond here. Okay, we're talking about things on this side bonding with things on this side. And ionic bonding occurs between two oppositely charged ions. Okay, and that we know. We have a positively charged thing and a negatively charged thing because it's an exchange of electrons. And so this causes an attraction. Okay. What we may not know is that the cation is the positively charged ion and the anion is the negatively charged one. That's some terminology that probably makes your life easier in order to name. Okay, so cation, the positively charged thing, the anion, the negatively charged thing. And then there are things that we call monatomic ions and then polyatomic ions. Okay, monatomic ions, those are mono, one, atomed ions. So those are things like Cl- or Na+ or Mg2+. Those are all single atom ions. Polyatomic ions are ions that have multiple, poly, meaning many atoms in it. So what we're saying is that this is the sulfate ion, and that whole ion has 2 extra electrons in it. It is a negatively charged polyatomic ion. There are also positively charged polyatomic ions. Let's see, like NH4, that's ammonia. And so what we're saying is that whole group here has lost an electron and had that electron go someplace. Okay, and so if we are going to think about how this process occurs between ionic bonding, we have to go back to our ionization energy. Metals, like my note says here, have low ionization energy. That means that they're able to lose electrons pretty easily. Okay, so metals readily give up electrons. So that's why metals are typically the cations. Okay, is because they are giving up the electrons. Nonmetals are going to be the anions typically because they have a high ionization energy. Now, it's not that they have a high ionization energy necessarily. What that means is they are less likely to give up electrons. And so if you're comparing something with low versus something that's high, let's say if you have sodium versus chlorine, which one's more likely to give up an electron? That means sodium is more likely to give up an electron, and chlorine, since it has a high ionization energy, that's not going to give up electrons. But that one electron that sodium is going to give up here has to go someplace. Well, where does that electron have to go? Well, it's going to go to chlorine. And by doing that, by having that transfer of electrons, okay, because that's what ionic bonding is it's a transfer of electrons, okay, that creates octets, okay. Sodium has one valence electron, and by losing it, it now has a stable octet. It goes back to the same electron configuration as neon. Chlorine, by gaining an electron, because it already has 7 electrons around it, Okay, going back to Lewis dot structures here. Okay, because it already has 7 electrons around it. I'm abbreviating, I'm putting them here. Now if I add this electron from sodium, it transfers here. Now there's 2, 4, 6, 8 electrons. It also makes an octet. So a lot of this is about making sure that we are satisfying the octet of these atoms. Now the other part is that opposites attract. Now we talked about that a little bit, but the more opposite they are, the more they attract. So if we have something like a 1 plus and a 1 minus, and we are comparing that to a 2 plus being attracted to a 2 minus, well, this attraction here and this attraction here, this one is going to be stronger. It is going to be a stronger attraction because it has more charge. Okay? The charge is bigger, the force of attraction is bigger. So that's what we mean here. Yes, we know opposites attract, but we also have to look at the size of the charge. Okay, so let's actually talk about naming. You may want to take a minute and write all this stuff. And so we're talking about main group elements here first, okay? And so we want to make sure that we know what the main group is. So main group elements, main group metals really are these guys here. Okay. Now there are a couple of main group metals over on this side of the periodic table. So like aluminum. But mainly what we're going to do is we're going to count for the purposes of this, well, we're not going to worry about any of these. But for the purposes of this naming ionic compounds, we're going to call all of these guys transition metals. Okay, so including tin and bismuth, okay, lead, thallium, indium, all of those things are going to be considered main or transition metals. The main group elements are really the main group metals are going to stick with aluminum and all of these guys over here. Not hydrogen. Hydrogen is special in so many ways. Okay, so let's go back here. Nope. That's not what I want. I want this guy. Okay. Okay, so the reason why we can separate these things out into main group metals, transition metals, and then the nonmetals is that the main group metals, this is so utterly important. Okay, it's that main group metals, the charge will never change on a main group metal. Okay, so if we have sodium, sodium will always become sodium with a plus charge. It won't become sodium 2 plus, sodium 3 plus, sodium 8 plus. Its charge will always be 1 plus. Now, with transition metals, when we name them, we always include the charge in parentheses, and that's because transition metals, including those that are over in the P block, can change their metal. So we can actually have tin 2 plus, and we can have tin 4 plus. So if we just talk about tin ion, we don't know which one. So what we're going to do is we're going to call this tin, and then we put the Roman numeral of the charge in parentheses. So this one is tin 2 ion. And then this one here will be tin 4 plus, or tin 4 ion. Okay. Now, 3 exceptions that prove the rule are silver, zinc, and cadmium. Silver, okay, always has a 1 plus charge. So because its charge will never change, we don't put its charge in parentheses. Zinc, same thing. Charge never changes, is always 2 plus, and cadmium is 2 plus. So I always say there's 1, 2, 3 that don't change, and their charges are 1, 2, and 2. So, right, 1, 2, 2. Silver, zinc, cadmium, 1, 2, 2. Okay, and then the nonmetals resemble that the naming that we're going to do in the that we have already done in the covalent compounds or the molecular naming. So let's name some of these things. Okay, so iodine. Iodine, that's a nonmetal, so that's going to be the iodide ion. Okay, aluminum is considered a main group metal, plus its charge can't change, so it's always going to be 3+. So this is going to be the aluminum ion. This is the sodium ion. Sulfide ion. And now we get into some of these that are a little more tricky. This is a transition metal. This is titanium. So we're going to name this titanium. Okay. But then we're going to put the 2 in parentheses because it's the titanium 2 ion. Transition metals, you need the charges. Okay. So this is nitrogen. That's the nitride ion. Okay. Notice that the negatively charged ions are the nonmetals, and notice that the nonmetals are the ones with the IDE ending. Okay, just something to keep in mind. Okay, so now iron. This is iron. I was going to write ferrium. Okay, this is iron, and this is the iron 3 ion. Okay, this is the iron. If we just left it as iron ion, we wouldn't know if it was iron 3+, 2+, or 6+. This is the iron 2 ion. And this one is the iron 6 ion. Okay, notice I'm using Roman numerals. So that may be something that you need to look up, how to use Roman numerals. Okay, but then here we have a negatively charged, this is the anion, and so this is bromine, so it's bromide. Okay, so there is naming ions, monatomic ions. Hopefully this helps you out. Have a great day.